So now let's start to answer the obvious question. How can we control or manage erosion? And the first part to that is working with the water, which is what generally causes the erosion. Now remember what determines the amount of erosion. When we're talking about water, it means more water is going to move more stuff. That's more erosion. Also means that faster water is going to move more stuff, more erosion. So controlling the erosion caused by water means you got to do one of two things. You either have to make the water go slower, or you've got to make it where there's less water moving across the ground. So how do we make water slow down?
So back there is the dam in Martin's Landing that makes Martin's Lake, which is there to help hold excess runoff. Well, sometimes we get too much runoff. It rains too much, the ground's already wet, whatever, and this lake can only hold a certain amount of water. Well, in that case, I've got to have a place for the water to go, because the lake can only hold so much. This dam can only hold back a certain height of water. So if the lake gets too full, the water comes this way. It comes down this little chute right here, and it's paved in concrete. The water will just flow out very quickly, which is what I want, because I need to get the water out of the lake quickly before the dam breaks. But then there's a problem. I've got water moving downhill very fast, which could cause us some real serious erosion problems. So here I'm at the bottom, and that water's coming out of the lake and rushing down this hill, which is what I want. What I don't want to have happen is that water to cause a lot of erosion as it goes over there to where the Chattahoochee River is, because I don't want it to take out the land that's underneath Riverside Drive. So look what we do in the path of the water. We put a bunch of big rocks in the place of the water, and as the water comes down this paved concrete chute and it's going really fast, it hits these rocks and it kind of stops for a second. Those rocks act as kind of like a speed bump for water, so that when the water gets through the rocks, and it will go through the rocks, it's now going a lot slower. And so when it goes to the river then and tries to cross Riverside Drive, it's not moving so fast, and it's not going to cause me erosion. These big piles of rock that we put in the way of moving water are called riprap. Riprap are piles of rocks that we put in the path of water to make it slow down, because slower water will not cause as much erosion as faster water.
Look at the concept here. Okay, we've got a road, and when it rains, we want the water to get off of our roads. We want it to get off the roads very quickly, so we encourage water to move very fast off of our roads. The problem is, once the water is going fast, it can pick up a lot of sediments, and you notice this drainage ditch over here. It'll get eroded very easily. So what's done is they put these piles of rocks in place of where the water is flowing. So as the water is coming down this drainage ditch, it hits the piles of rocks and it kind of acts as a speed bump. It slows down. Then it hits the next pile and has to slow down. These piles of rocks keep water from ever going too fast, which means it's going to go slower and therefore not cause as much erosion. You see there's a lot of places. Notice both of these drains, we've got some stuff, some rock put in the place of water, so that when the water comes down, it has to hit and kind of go around, or as it's coming out of this drain, it has to kind of weave its way and hit these rocks. That makes the water go slower, and slower water causes less erosion. Here's a case over in Gwinnett County where a guy had a house, and it was raining a lot up here in the neighborhood, and the water was coming down here, and the water was taking away his dirt. It was moving the sediments in his house. He was having too much erosion. So look what he did. He put some big rocks there in the way of water. And now when the water hits those rocks, the water slows down, and therefore it's lessening the amount of erosion that's going on. Something else we can do is when we make drainage channels, like either above ground type of storm drains or drainage ditches, you don't ever make them straight, you make them curved. If you make the drainage ditches curved, when the water comes through here, it kind of bounces back and forth on the sides, and therefore it slows down, it doesn't get going as fast, and slower water will not cause as much erosion as faster water. Same thing here. Looking at this, they could have very easily made this a straight shot, make this a straight drain, but they didn't. They made it curved. That way when the water kind of comes down here, it has to go slower, and that's going to cause less erosion than faster moving water. Some more concepts here coming off the house. They made it curved. Instead of going in the straight shot, they made it curved. Anytime you see drainage, make it a curved shape. It's going to slow the water down. Here's a combination of curving drainage. You'll see how it kind of curves like this, and we put some big rocks in the way of the water. So this is curved drainage and riprap. That'll both make the water slow down, cause less erosion. So what if the water's going downhill? If the hill's really, really steep, the water's going to move faster and you're going to get greater erosion. So if we want to prevent erosion on a hillside, we can make the hills less steep so the water doesn't go as fast.
Okay, so here we are in Panama, and we're in a place where it rains a lot. And they cut through the land to make the Panama Canal. And they had to make the land extra steep when they cut into it. And because it rains so much here, they have to worry about extra sediment coming down the hill and into the canal, which you don't want because then it fills up the canal with dirt and your ships can't get through. So what they did here was they cut those little flat steps into the side of the hill. And what happens when it rains up top and the water starts to come down the hill, every time it hits one of those little flat parts, it has to slow down a little bit. And slower water doesn't cause as much erosion as faster water. So by cutting those little flat steps, you don't wind up with as much runoff. You don't wind up with as much sediment down here where you don't want it. This process of cutting little flat steps into the side of a hill to help reduce erosion is called terracing. Once again, terracing is cutting little flat steps into the side of the hill, which makes water slow down so it doesn't carry as much sediment or cause as much erosion.
Here's a hillside alongside of a road in North Georgia, and you can see what's going to happen here. As it rains, the water comes down this hill. It's going to try to pick up stuff. It's going to get going really fast. But when it gets right here, it's going to slow down a little bit before it keeps going down the hill. Well, that little part where it's flat, that terrace, is going to make water slow down. You're going to have less erosion. Here's some examples, many different places around the country. Here's an example in Hong Kong, same thing. Water has to keep going down all these steps and it can't get going very fast, so therefore it doesn't cause erosion. We see this a lot in our area where people have very, very steep slopes they put their houses on. And you'll have a terraced yard. You'll have these little flat sections. Usually you put flowers in there or plants as opposed to grass because it's too hard to mow grass on that steep of a slope or in those little terraces. So the next time you see a house with a backyard like this, you'll know why it's there. It's to help prevent erosion.
So let's take a look at this situation here. Up there we've got some houses, buildings, certainly some roads and parking lots. It's going to rain here and that water is going to come down this hill. We actually wanted to come down that hill because we wanted to come over here and get in Martin's Lake, because this is my big retention pond that I want all of my excess runoff to go and hang out in. The problem is that's down a slope and the water is going to pick up speed as it comes downhill, and as it comes downhill, it gets going faster, it's going to pick up sediments which are then going to go into my lake, which I don't want. I want to keep extra sediments out of my lake, so I want to help prevent erosion. And look what they did here. They put some little steps in here. Now this isn't much of a grade. They could have made that just one gentle slope. But what they did was they put those steps in there so that when the water comes off of that surface, here it's flat. The water slows down a great bit. Well, then it comes down another step and it's also going slower. It comes down another step and it goes slower. Each one of these flat sections is a lot like terracing, which helps make water slow down. And slower water will not cause as much erosion as faster water.
So here's a diagram that kind of gives you an example, kind of summarizes how terracing helps to prevent erosion. Now, farms have significant problems with erosion because farmers are constantly tilling up the soil, and they're generally in places where it rains a lot. In the old days, farmers would plow up and down hills because that was the easiest way. Think like a horse to go up and down hill and plant little rows, and the water would come down the hill and just run right between the little rows of plants and wash the soil away. Well, now farmers know better and they plant across the grade. And now when the water goes downhill, it has to go over each little row of plants, and that acts as a little speed bump, keeps the water from growing too fast, and that lessens erosion. That's called contour farming or contour plowing, and that's when you plow the land across the gradient instead of up and down, and that will make the water slow down as it goes down the slope. Here's examples of this, and you'll see this when you look at the airplane, why farmers don't necessarily plant in nice, neat, straight rows anymore. An extreme case of that is they will terrace farms in places like in Asia where they have so much steep land and they have so much rain, they have to cut little terraces into the side of the hill, and you get how this works. Now when the water comes down the hill, every time it gets into one of those flat sections, it has to slow down a little bit, which lessens the erosion. Now there's other ways to make water slow down. In our area, you'll see this a lot. You'll see slopes in our backyards and they'll be covered with pine straw. Well, the pine straw that we see covering up slopes in our backyards is to help lessen erosion. Let's examine, how does just laying pine straw on the ground help? Well, here's what's going on. When the rain falls and the water has to kind of weave its way in through the pine straw, whether it's pine straw or hay or mulch or whatever, or pine bark, the water's got to slow down. It can't just go straight down the hill. It's got to work its way through the pine straw, which means it goes slower, and slower water doesn't cause as much erosion. The second thing that pine straw does, and any kind of ground cover does for us, slower water is going to take the time to infiltrate, and you're going to have less runoff. So once again, working with the water, we're making less water move down the slope, and we're making it move slower, so you're going to have less erosion.
So here I am at a construction site. You see, you got a big pile of dirt back here. That's a part of the process of construction. Well, this open dirt is very easily moved, and wind or water could pick it up and move it somewhere where we don't want it. So when they do construction, you'll notice one of the things that seems to always be done is you'll see this hay lying around on top of any exposed ground. And what happens is when it rains onto this pile of dirt, the water has to kind of work its way through the hay, which makes it slow down. And slower water isn't as likely to take this dirt and move it somewhere else where we don't want it.
So anytime you got new construction, you're building a road, building a neighborhood, whatever, you'll see this. You'll see how they will spread hay on the bare ground, because the bare ground is going to get moved around very easily, and it's going to rain before they finish their construction. This is actually required by law. And if a builder or developer doesn't have something covering the ground to keep the dirt from being washed away, they'll get fined, especially in a place like Roswell where they're very proactive about managing erosion. You'll see a couple different examples. You got hay, pine straw, mulch, pine bark. Any of these things are all materials that are going to help to limit erosion, because it makes the water slow down and it will increase infiltration. We looked at this in the Why Should I Care About Erosion? Here was water coming off the parking lot Alpharetta High School, and you can see it was eroding some of the land. What they did was they threw some pine straw right there. And the pine straw now makes the water slow down a little bit when it has to go through it, plus it increases infiltration. So it's going to lessen the erosion.
So up there we've got our new neighborhood being built with lots of exposed ground, and it's gonna rain, and the water is gonna try to flow down this hill, and it's gonna pick up a lot of stuff. It's gonna cause a lot of erosion. Well, here's one of the things that can be done to make it where the water doesn't pick up as much stuff. You have this roll here, this wide sheet of hay, and it's inside of a little webbing. It's inside of a little net. This is called an erosion blanket. It's a bunch of hay inside of a net that is laid down over the ground. And when the water comes down the hill, now it has to go through the hay and through that web, and therefore it moves slower. And slow water will not cause as much erosion as faster water.
Now, a straw wattle kind of works the same way. This is a big clump of hay, and it's put inside this little web or net. It's a roll of straw or hay that's put in the path of water. So water coming downhill this way and hits this straw wattle. Well, it hits it, it has to stop, which means it slows down. Now the water can still manage to work its way through, because you can see this, the hay is open. It's a webbing. The water can get through there, but it takes a little time, so that when the water comes on this side, it is now going slower. And slower water won't cause as much erosion as faster water. So a straw wattle is a roll of hay that is meant to make water slow down. So we get it, we make water slow down. But remember, erosion is also dependent upon the amount of water. So if there's less water, there will also be less stuff moved. So how can we make less water? Now we can't change the amount of rainfall, but we can control the amount of water that is going somewhere. So everything that we talked about in the last unit that makes less runoff will help reduce erosion. So bioswales, the water is going to go in here and it's going to hang out right there. It's not going to go somewhere where I don't want it. Well, it just sits there, and sitting water doesn't cause me a lot of erosion. Porous pavement means we're going to let water infiltrate the ground. We're going to have less runoff. Less runoff is going to mean less erosion. But we're still going to have runoff. We can't totally eliminate runoff. There's going to be always some natural runoff, and we want to help to try to prevent that runoff from causing too much erosion. So first thing we can do is let's limit how much of that runoff goes across bare ground. That way it can't pick up the sediments. If it can't touch the dirt, it can't pick it up and move it. So the first thing we can do kind of works hand in hand with what we've already got to handle runoff. Let's get runoff to storm drains and retention ponds without it touching the ground. Because if it can't touch the ground, it can't pick up sediments, and therefore it can't cause erosion. You'll notice this example here. A couple of houses, you see this a lot, where it's going to rain and they have drains that are going to push the water straight out into the street. We know where this goes. This goes to the storm drain. Same thing here. This downspout is putting water straight into the street and the storm drain. So no water is moving over the dirt. So all of that water can't pick up any sediment, and therefore you're not going to have erosion. This guy right here, he doesn't want erosion next to his house. He doesn't want the dirt over here being moved away from his house. Now he's still going to have water coming off the house, so what he does is he makes this downspout spit the water out over here. So we have the water away from our house. We have less water next to the house, so we're going to have less erosion next to our house, especially where we don't want it. Now for roads, especially roads on steep hillsides, they use drains and pipes. What these pipes are doing is getting the water away from the slope. So it rains over here, and there's a storm drain up there that collects it, and we don't even let the water run down this hill. We basically make the water go through the pipe and down here. So if you use drains and pipes to not let water touch the soil, now there's still going to be some rain that hits this, but all of the runoff, all of the water that hit the road that became runoff, we can send it someplace with drains and pipes so that it's not even allowed to touch the soil, and therefore won't cause erosion. So we're still going to have water going downhill. Let's see what else can we do to keep stuff from being moved, because it's naturally going to rain on a hillside.
So here we can see a really steep slope where stuff is going to want to move very easily, and we don't want stuff moving down this hill and winding up out here on our road. If you look over here, you can see what this hill is made out of. It's pretty soft, loose material that would get moved very easily. And of course, this hill is really, really steep, so gravity's going to want to move the stuff very easily. So what do here? You'll notice that the hill is entirely covered. It's been paved over in concrete. Now what does that do? Now when it rains, the water is going to hit the concrete and just slide off and over here into this drainage area. Well, we don't let the water touch that small soft material at all, so therefore the water can't move it. So this is a pretty extreme measure, and this is, you can coat a hill in concrete, and what that does is it keeps the water from touching the material at all, and therefore it won't be able to move it. So once again, in summary, one other method that can be used to help control erosion is to pave a hill in concrete. That way the water cannot touch the soil at all, and if the water can't touch the soil, it can't move it.
And they do this all over the place. It's not just a United States problem. You see, here's some examples where they put concrete on hills in Japan, Costa Rica, and Alabama. And the whole point of putting concrete on the hill is make it where the water can't even touch the hill at all. If it can't touch the sediments, it can't move them.
So let's talk about battling creep erosion. Here I've got a really steep hill. It was so steep that we had to build a retaining wall to help keep the sediments up here and keep the shape of the hill. Well, it rains and that hill is going to get wet. And remember, erosion is the movement of stuff by water or wind with the help of gravity. Well, when the water gets in this soil, it's still going to get pulled down by gravity. So if this soil gets really, really wet, it's really going to try to push on my wall. And I got to be careful because my wall might eventually be pushed over by that slow movement of the soil. You can actually see it here, how this wall is cracked now at the joint. This section of the wall was being pushed on enough that now it has come separated a little bit from this one. It's not real bad, but if it continues over time and too much pressure builds up, this section of the wall could fall over and I lose the slope of my hill. So how do we help keep this from happening? Well, remember, this is caused by water moving through the soil behind the wall. So if we let the water move through the soil, then it'll move on down the way and we won't have the creep erosion. It's one of the reasons why you have these right here. You have these little drains that allows water to be drained out of the soil, and that way the water will flow out the bottom and leave the dirt behind the wall and my wall won't get knocked over. Notice along the top we have a drain for water, and what this does, it allows the water to get out from behind the wall and go somewhere else so that it doesn't soak into the ground, make the ground heavy and want to push the wall over. So once again, the number one way to fight creep erosion is going to be do something with the water, because it's the water getting into the soil that's causing the erosion.
Here's a case where a retaining wall was not built correctly and it actually fell over. You can see that this part of the retaining wall here is a different color than this part here. You can see this part here where the new bricks were put in. This retaining wall wasn't put in with a drain, and too much water backed up behind it, and the water is gonna move, and it built up enough pressure that it pushed this wall over. So you got to let the water go somewhere, because the water is going to cause erosion. It's going to move stuff, and if that stuff is behind your wall or your house, it can move those materials. Now, dams. Dams are another way that we can control the amount of water. Remember what a dam does? It controls the amount of water that flows through a river. And if we know it's going to rain a lot, and we're likely to get a lot of extra water going into a river, and I know, well, that river is going to go and move a lot of stuff that I don't want moved, I can hold the water back behind the dam. Dams also work for not just flood control, but they also work for erosion control, because they control the amount of water that goes through a river or stream. And if we can lessen the amount of water that's coming through a river or stream, we can lessen the amount of erosion. So, final ideas here. Big point to this whole thing. To limit erosion by controlling water, you got to do one of two things. You make water slow down, or you make less water. Those are the two key points.